talk to my boy Ty. Um, Twins, because the Angels lost, Twins are now in the postseason. So, yay, Twins. Yes, they did. F plus G. We are now going to go over 4 derivative rules now that we know the power rule. The derivative of F plus G is F prime plus G prime. We've actually already used that rule. If you subtract, it's F prime minus G prime. And so when people get to the product rule, they want to write F prime times G prime. But that is not the case. Yesterday, I was subbing for somebody, and they were watching a video, and I got bored. So I said to myself, I've never proved the product rule. And so I sat down and did it, and I got it. I checked the book. Very good. I noticed that I was a boring person at that moment, and I said, I will no longer be a boring person. So I will make that change. Thank you for pointing that out. Oh, man. You know, and I used to think that he just never listened. And here he does. He does. So we have a product rule, and we have what we call a quotient rule. These you have to memorize for the test. I will not give these to you for the test. The product rule is F prime times G, which means the derivative of the first function times the second function left alone, plus the derivative of the second function times the first function left alone. If you would like to see the proof, come see me after school. I'd be happy to show it to you. The quotient rule sets up very nicely. F prime G, G prime F, minus. And then all divided by G squared. I do that for a fact because a lot of times people say quotient rule, like, oh, it's so confusing, I'll never get it. It's just the same thing as the product rule, except it's got the minus, and then just remember to divide by G squared. It's not that big of a deal. All right. So flip over to this page. Allow us to differentiate the following functions. We have x squared divided by x minus 1. We would like to find the derivative. What people do on the test, and I will award you 0 points for this, is they take it 2x divided by 1, so the derivative is 2x. They take the derivative of the top, derivative of the bottom. I award you 0 points. It is not. So therefore, f prime of x is, the rule says we take the derivative of the top, 2x, close, times the bottom left alone, minus the derivative of the bottom, which is 1, times the top left alone. All divided by the bottom squared. Not the derivative of the bottom, but the bottom squared. Derivative of the top times the bottom left alone. Minus, you got it now? G's the bottom. You don't have to. Okay. So, now, it's simplified if you have combined like terms. We do have some terms we can combine here. If I distribute the 2x, I have a 2x squared minus an x squared gives me x squared minus 2x all over x minus 1 quantity squared. leave the denominator in factored form, this will help you identify something important. For example, if you look at the original function, that function is discontinuous at some point. What x value is it discontinuous at? It's discontinuous at 1, because if you plug in 1, you would get 0 in the denominator. It would be undefined. It's a vertical asymptote that occurs at 1. Okay? However, you look at the derivative, okay? And where's the derivative discontinuous? 1. So if you can't take the derivative at 1, if it's discontinuous at 1, then you shouldn't be able to take the derivative at 1 either. So those should match up. Okay, the second one, instead of using the quotient rule, I'll use the product rule. Okay? Yep, this is the answer. What else would you do? Okay, I just want to be clear. One is not simplified more than the other. Just one is factored and one is not. If you'd like to write this as x times x minus 2, that's fine. It's the same thing, right? But if we don't combine like terms, combining like terms is a way of simplifying. Combining like terms, getting rid of negative exponents, getting rid of irrational numbers in the denominator, stuff like that, okay? So we look at this example. I'm going to do this example 2 ways because you're going to be asked to do it 2 ways on your homework assignment. And we are going to use it by using the product rule. But before I do the product rule, I'm going to actually multiply it out to see what I would get if I took the derivative of the polynomial. Okay? So let's multiply it out and see what we get there. 2x squared times 5x squared is 10x to the 4th. And then what do I have cubed? Negative 4x cubed minus 30x squared plus 12x. Good. So now I'll take the derivative using the power rule. And what do we get? $12x squared. Okay. So that's one way to take the derivative. Another way to take the derivative is by using the product rule. Now, I'll admit, folks, I would never do this problem using the product rule. I would just multiply it out. And so you may ask, why on earth do we learn the product rule then? Because sometime I'm going to want you to take the derivative of natural log of x times sine of x. And you have to use the product rule in that scenario. Okay? So right now we're very limited to the things we know how to take the derivative of. But trust me, we're going to want to take the derivative of a lot of different things. Okay? So I'm going to choose f to be 2x squared minus 6. I'm going to choose g to be 5x squared minus 2x. So derivative of f is 4x times g plus derivative of g, 10x, times it's called a binomial. But, yeah. All right, 4x times 5x squared is a 20x cubed. 4x times negative 2x is a negative 8x squared. I'll now multiply these out. 20x cubed minus 60x minus 4x squared plus 12. If I combine like terms together, how many cubes do I have? 40x cubed. That takes care of those squareds. Negative 12x squared minus 60x. Is that the same as what I had up there? It is. when I multiplied the top out and created a polynomial and take the derivative, that's the same as using the product rule for the derivative. You'll get the same answer either way. What? You can. I'm just telling you that it's like, well, then why even learn the product rule? Well, because someday you're going to use it to find the derivative natural log of x times sine of x and a lot of other stuff. And I'm going to give you a couple examples today where you have to use the product rule. You don't have any other option. Okay. Let's do another example here. Okay. Flip it over. Let's go to f. What rule do you think we should use for f? The quotient rule. Now, a lot of people, when they look at this, are like, oh, this just looks like it's going to be horrible. It's really not that bad at all. So, f. So, the derivative of the top is 0 times the bottom left alone. 0. Isn't that nice? Minus the top left alone. So, plus 3 times the derivative of the bottom. All over bottom square. We don't have to FOIL it out. We don't have to multiply it out. We can just we got 36x cubed plus 12x minus 3 all over 3x to the 4th plus 2x squared minus x 20 squared. That's the derivative. Now, just imagine using f of x plus h minus f of x all over h for that. That'd be challenging. Okay, so back to Carter's point. Why use the product rule? Here's an example where you have to use the product rule. Go get some brain food, come back smarter. Almost done. Okay, so now we want to find these derivatives using a table. So we've got this grouping here, and then we'll be done for the day. But we want to find f minus g prime of 3. What this means is we want to find f prime of 3 and subtract g prime of 3. Well, if you look at the table of values, we got x values, we got f, we have g, we have f of x, or f prime, we have g prime. So what's f prime? Yep, -2. And g prime, -1, which makes -1, right? So f plus g prime of 4 is f prime of 4 plus g prime of 4. So that's going to be 1 plus 2 is 3. Carter, what do you think people do that's incorrect when they get to letter C? Yeah, they just take 5. There you go. 3 times 1, so we get 3. Okay? You can't do that. You have to do f prime of 5 times g of 5 plus g prime of 5 times f of 5. Right? I use the product rule. F prime of 5 is 3. G of 5, 0. G prime of 5, 1. F of 5, 6. So 6 is my answer. You try letter D on your own. What do you think? Okay, so this is stuff that these are great questions to use for the AP exam, and I love these questions. You will have these questions on your test. You will have them on the final exam. You'll see these throughout the year. This tests your true understanding. It says write an equation for a line, tangent to x equals 0. If I write an equation for a line, what two things do I need? Let's start with the point on the line. What's my x value? How do I figure out the y value? Can you get? Isn't that nice? Okay, so the AP exam will try to work it out so you come out with very nice numbers as well. If I want to find the slope, how do I do that? Sure, y2 minus y1 over x2 minus x1, but that's with 2 points. I want to know at 1 point. What allows us to find slope at 1 point? Derivative. How do we find the derivative? Quotient rule. Let's take the derivative using the quotient rule. F prime of x is equal to derivative of the top, 4 times the bottom, x cubed minus x plus 2, minus the top times the derivative of the bottom, all over the bottom squared. Here's why I love this problem. Everybody gets here and you want to simplify. Don't simplify. Does it ask you to provide a simplified derivative? Does it ask you what the simplified version of f prime is? It just wants the stinking slope, right? Does it matter if I plug in 0 now or if I do it after I simplify it? So on the test, or on the AP exam, don't bother trying to simplify. Just plug in 0. So 4 times what? 2 is 8 minus 0 over 2 is whoops. I'm sorry. The bottom is squared. The bottom is squared. 2 squared. So I'm sorry. So we get 8 over 4 is 2. Sorry about that. Forgot to square the bottom. I got excited about my teaching point. What? So plug in the top, we get 8 minus 0 over 2 squared, or 8 over 4 was 2. So therefore, the equation for the line is y equals 2x. Done. No big deal, right? So then you get this kind of a problem on the test, and you got to find the equation for the line tangent. You say, well, I want slope, and I want my point on my line. Okay. Well, what's the point on the line? 0, you plug it in, you get 3. See how quickly we can do that? It's kind of nice, isn't it? So you go through that, you get 0, 3, and then you go to take the derivative for the slope. Now, here's what some people do. And I can tell really who's been focusing and preparing in class and who hasn't. Because I'll get times where people actually multiply this all out. So you get 12 different terms. And then not only do they get the 12 terms, they actually go through and simplify it as well. And the chances of you making a mistake are highly likely. So don't multiply it out. Just use the product rule. What's the derivative of the first part? Minus 6, right? Times plus yes, Jake, you're right. We do 2x minus 1. And then here's how I organize my work when I do it. I happen to be plugging in 0 here. And so what am I going to get here? Negative 6 times 1 plus 3 times negative 1. So people forget their multiplication or their addition or what they're doing. This is what this results to be. So negative 6 times 1 plus 3 times negative 1, negative 9er. So we have y equals negative 9x plus 3. So although this looks like a ridiculous problem to find an equation for line tangent there, it's no big deal, is it? Hunter, question? No need to simplify, just plug it in. Okay,